Well, thank you. Thanks, Todd. Thanks, Nicole and MWA for helping us set this up for today. And thank you all for joining and listening. This is Stormwater 101, EGLE permitting as it relates specifically to wetlands, lakes, and streams. So today we're going to briefly talk about stormwater management under Part 301 and 303 in particular, but this is the basic outline of what we're going to touch on today. The biggest takeaways from today's presentation will be knowing when permits are required, avoidance and minimization techniques and best management practices, and where to find more resources and how to best coordinate with EGLE staff. So to start, I want to clarify the general structure of the Water Resources Division because there are multiple programs in WRD where permits for stormwater can come into play. The two umbrella programs are water quality and water resources. So under the water quality program is where you will find the permits section, which is where the NPDES program sits. And NPDES is the National Pollutant Discharge Elimination System, which is a federal program that Michigan has been granted the authority to implement, similar to how we have Section 404 of the Clean Water Act authority to implement permits under Part 301 and 303. The NPDES program addresses point source water pollution and imposes effluent limitations. And within that program, and depending on the area, the facility, the activities proposed, there's the construction stormwater permits, industrial stormwater permits, and MS4, which stands for Municipal Separate Storm Sewer System permits. But under the Water Resources Program, which is what we're going to be focusing on today, this is where you would get permits, specifically stormwater-related permits for construction-related activities within or impacting inland lakes, streams, wetlands, critical dune areas, and Great Lakes bottomlands. Both the Resource Program and the Water Quality Program regulate stormwater, but under different criteria and circumstances. So EGLE does often coordinate to be consistent on what we are requiring for treatment. Our resource permit categories even reference the NPDES permitting requirements, and there are several water quality programs that deal with the compliance for these permits. If you submit an application for any facility or development that is discharging to waters of the state, EGLE staff are looping in each other. The resources staff are looping in water quality, stormwater district staff, either to double check that proper NPDES permits have been obtained or to potentially work together on any stormwater management that may be proposed. Let's talk a little bit more about the statutes that pertain to stormwater and where our permitting authorities come from. So starting with Part 31 of the NREPA, which is Michigan's Natural Resources Environmental Protection Act. This part of statute prohibits a discharge into waters of the state that is or may become injurious to public health, safety, or welfare, domestic, commercial, industrial, agricultural, recreational, or other uses that are made or may be made of such waters, value or utility of riparian lands, livestock, wild animals, birds, fish, aquatic life, or plants, or to their growth or propagation, value of fish and game. Part 31 also requires EGLE to protect waters of the state for specific designated uses, such as navigation, fisheries, recreation, fish consumption, public water supply, and more. Your water quality district staff are your contacts for working through compliance issues of point discharges. And under Part 31, you will also work with Part 31 floodplain engineers on project files that include activities within regulated floodplains. Under Part 303, most stormwater discharges often come into play through maintaining a use in wetland, which is an activity that would significantly alter the biological, chemical, or hydrological characteristics of the wetland. A lot of stormwater management plans we receive have treated stormwater discharge being directed towards a wetland. If the discharge is ultimately going to a wetland, then it is likely regulated, but there isn't a rule of thumb on distance. If the wetland is intentionally being used for stormwater storage or treatment, distance doesn't matter, and it would be regulated because it's maintaining a use in that wetland. Because of this, if your application doesn't contain this information, you may see correction requests from EGLE staff that are trying to identify whether the wetland resource is part of stormwater management on site and what the impact to that wetland will be. In some cases, we have determined that if a treated discharge is so infrequent and small that we wouldn't require a permit for that discharge to wetland. And an example of this is maybe a basin that only has an emergency spillway to wetland. It doesn't discharge unless there's a significantly large storm event. In those certain cases, we have determined that the rate and volume is not going to have an impact on that wetland and alter the function and characteristics of the wetland. It's basically not being used, quote unquote, used insofar as the wetland is necessary for stormwater treatment or storage. But reach out to your local district staff if this question comes up. Generally, we are asking for stormwater management details like rate of release, volume released, existing wetland type, if there's potential for infiltration prior to reaching the wetland, items like that in order to determine if the discharge is maintaining a use in wetland. If the applicant is proposing to maintain a use, then mitigation would be required if the discharge is going to impact more than 1/3 of an acre, or even less than 1/3 of an acre in some cases. So this can happen when the volume of water released is significant enough to convert scrub shrub wetland to emergent wetland or open water habitat. However, I'll caveat all this by saying this should hopefully be a rare occurrence because there will likely be a viable alternative that reduces these types of impacts through proper stormwater management and use of upland alternatives. Some wetland within stormwater basins may not be regulated if it meets this specific exemption in Part 303. Which states that a wetland that is incidentally created as a result of construction and operation of a water treatment pond, lagoon, or stormwater facility in compliance with the requirements of state or federal water pollution control laws is not regulated under Part 303. So when approaching this exemption, think about the definition of incidentally. Was there wetland in that location prior to the facility being there? So typically applicants will come to EGLE and ask us to confirm an exemption under this section of statute. But in order to do that, we may need additional information, which can include documentation of the purpose or use, like site plans, local permits, previous state permits, approved stormwater calculations for what was constructed, et cetera. And also a historical aerial site review dating to immediately before the operation existed in order for us to be able to determine whether that exemption criteria is met. Stormwater discharges or stormwater facilities can also be regulated under several Part 301 provisions, including placement of a structure or dredge or fill on bottomlands, enlargement of an inland lake or stream, construction of a waterway where the purpose is an ultimate connection with or within 500 feet of an inland lake or stream, or connection to any waterway to an inland lake or stream for any purpose. A lot of stormwater management permits we see under Part 301 are for treated discharges to an inland lake or stream that disturb below the ordinary high water mark, or for the excavation of a basin within 500 feet of an inland lake or stream. So we do have a couple of permit categories that address stormwater management for these situations, and I'll touch on those in a few minutes. But you'll want to look to those project categories for some best management practices. Something to keep in mind here, and I think something that gets forgotten a little bit, is just because an activity might be exempt under Part 303 does not mean it is also exempt under Part 301 or other statutes. So Part 301 and 303 do have parallel exemption language here and there, but there is not a similar exemption for stormwater facilities under Part 301. So it's always a good idea to check both statutes if you're dealing with multiple water resource types. This in particular comes up a lot for dredging existing stormwater basins or excavating new basins below the water table in particular. It may meet that exemption under Part 303, but if the pond is near a stream or a lake, then it might need a permit under Part 301. So regulated activities under Part 301, again, says to construct, dredge, commence, extend, or enlarge an artificial canal, channel, ditch, lagoon, pond, lake, or similar waterway for connection to an existing lake or stream, or where any part of the artificial waterway is located within 500 feet of the ordinary high water mark of an existing lake or stream. All of those situations need a permit under Part 301. Other statutes could come into play when considering stormwater management facilities or discharges. For example, depending on size and design, some detention basins may fall under the authority of Part 315. A permit is required under Part 315 when a structure that is 6 feet or more in height and impounds 5 surface acres or more at the design flood elevation is constructed. Part 315 requires dams to have a specified spillway capacity based on the hazard rating. Dams have to have a spillway capacity that is capable of passing the 100-year flood or the flood of record, whichever is greater. So if you are submitting an application for a larger basin over 5 acres with some sort of spillway control, EGLE will loop in the regional dam safety engineer so they can confirm whether or not it would be regulated under Part 315. And then your application would also need to be reviewed under Part 315 statutory criteria if it is. Okay, so we've gone through different parts of statute, different programs that incorporate stormwater management in some way. Now let's talk a little bit more about stormwater impact and design and how that's reviewed under the resources program specifically. So whether it's utilizing all the best technology and site conditions as much as possible, stormwater infrastructure in or around water resources are likely going to result in some kind of impact. So the goal is to reduce those impacts as much as possible through those good management techniques. Stormwater impacts can result in either water quantity degradation or water quality degradation. And EGLE reviews for both under Parts 301 and 303. So under those parts of statute, there is specific language that speaks to water quality and quantity permit application review criteria. So with water quantity degradation from stormwater, we're talking about potential changes to stream flows, changes to channel width and depth from more erosive forces, changing wetland hydro periods, conversion of wetland type, downcutting channels within wetlands. And then with water quality degradation from stormwater, we can see issues from increased sediment loads, increased pesticides, nutrients, fertilizers, metals, or organic material within the water resource that may have cascading effects on the system. EGLE staff often get questions from the applicant over needing to provide stormwater details that have gone through a county level approval. While county approval and design standards are, of course, very important, they're there for a reason. A lot of county standards are more heavily focused on water quantity and reducing flooding for the local community. And again, EGLE does review for quantity as well, but water quality and resource impacts is equally important in our review, and it's often interconnected. So stormwater designs should be incorporating best management practices that address those as well. So a lot of EGLE questions throughout the application process related to location, discharge details, outfall structure design, pre-treatment options. Those are all surrounding how the stormwater could degrade the resource over time through those impacts that I mentioned on the previous slide, like the conversion impacts, change of wetland type, vegetation changes, invasive species, downstream degradation, sediment mobilization, and more. Those are what we're trying to get at with all of those questions. And these are just some recent examples of stormwater basins or infrastructure that failed at protecting water quality or the resource quality. Some of these pictures are also showing how it failed at water quantity as well. So in these pictures, we're seeing increased sediment, design failures, algae growth from increased pesticides, and in general systems that have a negative impact on the resources around them. This is a panoramic shot of a recent large stormwater infrastructure project where stormwater was funneling into this structure upstream and sending muddy water down gradient and dragging the erosion blankets with it and impacting the surrounding resources. So two things. First, this is something that definitely needs a permit. This is one example of where some applicants might have considered the construction activities of this facility to not need a permit because it was constructed in upland and intended to control and treat water before it reaches wetlands. But you can clearly see how the discharge is negatively impacting wetland. It is discharging directly to wetland. And second, this wasn't stabilized properly, and through rain events is sending pollutants and sediment directly into this wetland. So, we aren't going to touch much on soil erosion and sedimentation control in this presentation, but that can be a very important aspect of maintaining water quality with any stormwater project as well. So to ensure that a project is avoiding and minimizing these types of water quantity and quality impacts, EGLE will require stormwater management plans that address these issues. So typical historical quote-unquote solutions to flooding problems have been things like channelization, removing obstructions, installation of larger capacity storm drains, and the primary goal with those types of projects is to get the water out of the community and downstream as fast as possible. However, more often than not, channelizing the systems that transport the runoff passes the problem on to a downstream community. The channelization of streams, the installation of storm drains results in the runoff reaching a location quicker. And so this graph on the right is showing the impact of urbanization on flood peaks, but it's also showing how proper stormwater management can reduce stormwater impacts better than what the result of passing on the problem downstream can be. So after urbanization and before proper stormwater management, you would see a flood peak that is larger than pre-development conditions and a flood peak that gets downstream quicker and brings the problems downstream faster. But with proper management, you can have a peak that is the same discharge pre-development. So we'll get into some specific BMPs that can be used to address these peaks in a bit, but an important policy for the resources program is that we want to avoid using natural wetlands for storage or treatment of stormwater, and maintaining pre-development runoff amounts of clean water to natural wetlands is something EGLE is pushing for. So in other words, we don't want to starve water resources of its natural source of clean water, and we don't want to reduce the function and quality of those wetlands or resources in general. We also don't want to see these pockets of wetlands totally eliminated from the landscape with development projects, either through fill or by eliminating natural flow pathways of surface water to those wetlands. The elimination of wetlands, depressions, small ponds results in a greater runoff volume reaching the rivers and streams more quickly. So you're seeing flood peaks that are increased and downstream river levels that will rise more rapidly. And then the elimination of natural storage areas can also lead to reduced base flow in streams during dry periods, which will degrade stream habitat overall. So we want to see protection of those important resources and maintaining clean water to those resources. There are a ton of best management practices out there for stormwater that include both structural and non-structural methods to reduce degradation of surface water. I'm going to go through some basic examples over the next few slides for you to be considering when designing and consulting with applicants for these types of projects. You can always consult with EGLE Water Quality District staff on these methods, but right now, before we jump into different types of BMPs, I do want to call attention to the fact that by using stormwater BMPs, It is a method of avoiding and minimizing environmental impacts and fits into our review criteria under parts 301 and 303. So the general permit and minor project categories were developed to include important best management practices that allow us to expedite our review. So if that is not being utilized, you are adding time to your processing review. And I've said this in other webinars recently, but I encourage applicants to design according to these categories. Instead of immediately applying under the individual public notice permit, consider modifying your project design to meet the categories. So in this way, you're showing that you're utilizing the least impactful alternative and avoiding and minimizing impacts to the greatest extent by incorporating best management practices. Even if your project as a whole is still a public notice permit, it is very helpful for EGLE staff to know that any stormwater design, like your outfalls, are still meeting MPGP category conditions. So I would recommend explicitly stating that in the narrative descriptions. And we have a few different stormwater related categories in both GP and MP types. So we have GPZ, stormwater management facilities for inland lakes and stream impacts. This is specifically for construction and maintenance of stormwater management facilities, including ponds, detention basins, retention basins, and ongoing maintenance dredging. It does only apply to Part 301. So you would not be able to use this specific category for Part 303 regulated wetlands or within regulated floodplain, but you could potentially stack it with GPM, which is for maintenance of stormwater facilities in wetland that are not exempt under Part 303. So the descriptions explain exactly what it can be used for this category. It is only for maintenance, not construction, but it includes dredging or filling, no more than half an acre of dredge and fill in wetland. Proper handling of contaminated material is a part of this category. And then under our MP categories, we have MP 50 for stormwater outfall structures. This can be stacked with the GP and can be used with any of the listed statutes. It must meet NPDES regulations. It must use best available technology for pretreatment. It can't interfere with navigation or be designed in a way that impairs the resource. It can't change the ecological type of the wetland and minimize impacts from storage. Limited use of riprap and excavation for the outlet is also included in this category. And we do also have MP 38, which sometimes is used for construction or maintenance of stormwater basins. This category does include Part 31 if a floodplain permit is also needed. So this could be used for stormwater basins constructed within 500 feet of an inland lake or stream that are permanently holding water. It can also be stacked with MP 50. It can't be in line with a stream or lake, less than 5 acres in size, and again, managing spoils appropriately. But keep in mind that in addition to proper design and best management practice implementation for stormwater, common feasible and prudent alternatives would be simple modification of the project layout or scope. EGLE is always going to ask the applicant to utilize available upland if it appears there's upland to utilize, or to provide alternative layouts considered for moving stormwater out of regulated resources if they're proposed there to begin with. In some cases where site limitations are due to local restrictions, and especially if the applicant is proposing stormwater in existing wetland, EGLE may ask the applicant to request a variance from the local unit of government. Good stormwater management is going to utilize best management practices that we're going to want to see as feasible and prudent alternatives. Green infrastructure, in addition to standard detention, can further avoid and minimize impacts to wetlands, lakes, and streams. These BMPs often encourage working with the landscape by utilizing green spaces, paying attention to topography, natural waterways, reducing construction impacts, reducing impervious surfaces and sedimentation opportunities. For larger developments or other sites that need stormwater management through the water quality permit programs, like the industrial sites, MS4, Part 91 sites, applicants need to provide detailed stormwater management plans for district staff to review under the permit process. And we have been requiring green infrastructure to be incorporated into site plans for a lot of large-scale developments where those opportunities exist. Comprehensive stormwater management is especially important in areas where there's been high historic loss of wetlands. So demonstrating in your application that stormwater has been thoughtfully considered with the landscape and impacts to resources have been avoided to minimized is really important. Okay, let's take a look at some examples of stormwater design considerations and how to incorporate those BMPs. We'll start with detention basins, as this is probably the most common stormwater management method we come across. There are many different types of detention basins. There's wet detention, dry detention, constructed wetlands, underground systems, and bioretention are all examples. So when EGLE staff are reviewing these types of projects, we are looking to make sure that these are properly sized and implement first flush and channel protection standards if possible. When we are talking about feasible and prudent alternatives, we are often talking about something other than simple dry detention basins. Dry basins can address those water quantity issues, but they don't address water quality issues that EGLE is equally concerned with. So this graph on the right illustrates the concept of first flush, which is when in the first half an inch or so of a rain event, stormwater runoff will result in concentrated pollutants being loaded into storm drains and receiving waters. And then as the rain continues, there are fewer pollutants available to be carried by the runoff, so the pollutant concentration becomes lower over time. The overall issue with dry detention basins is that most of the pollutants that have accumulated within the drainage basin since the last rain event are then flushed into the stormwater system in a very concentrated form with the next storm event. It's this initial pollutant loading that should be the primary concern of any stormwater management design, and why we want to see other structural BMPs or alternatives in place or in addition to dry detention basins. For example, pre-treatment of those suspended solids through things like forebays or infiltration measures. So this table on the left is sourced from the Center for Watershed Protection, and it's showing pollutant removal percentages for different pollutants compared across different stormwater management options, which typical drain dry ponds is outlined in red. And those are the lowest percentages of pollutant removal across the board. There are several ways first flush can be treated through stormwater best management practices, typically through properly sized designs that reduce total suspended solids by 80% or achieve a discharge concentration below 80 milligrams per liter. So this chart shows some practices that can achieve that and its associated total suspended solids removal rate. So at the top, you'll see that infiltration basins, wetland swales, vegetated filter strips, all can have 80% or higher TSS removal rates, whereas things like catch basins, conventional dry detention, cisterns have much lower TSS removal rates. The stormwater programs also have requirements that post-construction runoff rate and volume are not to exceed the pre-development rate and volume for all storms up to the 2-year, 24-hour storm event at the project site. So this chart shows what that rainfall depth would be for counties across the state and what those sizing requirements of first flush should be based off of. These first flush requirements are mainly for stream channel protection. But something else to keep in mind is that with climate change and storms increasing in frequency and intensity, proper sizing recommendations from EGLE will be affected. So some local municipalities are also taking this into consideration and trying to develop minimum standards that are based on larger storm events. But just please know that this is a conversation we're having statewide as we are dealing with increased flooding and old under-designed systems. If you are proposing detention basins in general with your project, there are some basic BMPs that we want to see used. And again, these can be used in combination with others. There should be regular maintenance of vegetation and sediment removal. Again, we have that Part 303 exemption language for stormwater basin cleanout if it was constructed in upland and constructed as a stormwater basin, but we also have the expedited permit categories if it's not exempt. If it's designed as a wet detention basin or constructed wetland, you should be able to show that is a natural high groundwater table. Otherwise, explain how the water will stay in the basin, maybe through installation of impermeable soils or a liner. There should be forebays for collecting and removing sediment. There may need to be a dewatering mechanism like an agri-drain structure for wet basins and constructed wetlands. And there should be emergency overflows and energy dissipators at all the outlets. Location is super important for these types of structures. Obviously, they should be located down gradient in order for them to be most effective and in the developed area of the site in order to collect as much runoff as possible from impervious surfaces. They should not be constructed on steep slopes, nor should there be a lot of earthwork or soil disturbance in order to regrade it to a shallow slope for installation. Tree removal should be avoided for installation as much as possible, as that worsens runoff potential. As a general rule of thumb, they should be not constructed within 10 feet of the property line or within 50 feet of a private well or septic system. The applicant can consider multiple BMPs distributed throughout the site if one detention basin cannot address all of the runoff. And the basin should not be constructed in areas with high quality ecological areas like vernal pools, wetlands, mature forest, and they should not be constructed in well draining soils. If you are proposing something in a well-drained soil area, then we would argue that you can propose a different stormwater management BMP that looks more like infiltration, which we'll talk about in a minute. Wet detention basins, which can include extended detention basins, constructed wetlands, or wet ponds, are permanent water bodies with year-round control measures. This information, by the way, is all outlined in the LID manual, LID manual, which I'll touch on in a second, but highlighting some best management practices for this construction, it should be designed to mitigate runoff peak rates for 1 to 100-year rainfall events. Max water depth is typically 8 to 10 feet. There should be at least one forebay, some kind of upstream pretreatment. In order to achieve 60% total suspended solids removal rates, a 24-hour detention time is necessary with an extended detention basin. And again, we're looking for that 80% minimum. So that's just something to keep in mind there. The minimum length to width ratio of 2 to 1 is recommended to maximize sedimentation, and sizing is generally 1 to 3% of the total drainage area. Multiple basins would be required on larger sites. This is an example of a typical extended wet detention basin showing all of those BMPs. It has permanent pond, emergency spillway, outfall with dissipators through riprap, sediment forebay. Okay, so I referenced this earlier, but this is a great resource that I highly recommend using, and one that I am referencing quite a lot for this BMP information. This is the 2008 SEMCOG Low Impact Development Manual. SEMCOG stands for Southeast Michigan Council of Governments. This manual provides communities, agencies, builders, developers, and the public with guidance on how to apply low impact development to new, existing, and redevelopment sites. So the manual provides information on integrating LID or LID from the community level down to the site level. It not only outlines technical details of best management practices, but it also provides a larger scope of managing stormwater through local policy decision, including ordinances, master plans, watershed plans. So this is a really great resource for everyone. It is online if you want a digital copy. And this is something that you should definitely take a look at when designing projects and talking to EGLE about stormwater alternatives. EGLE staff will refer to this manual a lot when reviewing projects with stormwater components. So low impact development, just to further explain, is really the cornerstone of stormwater management with the goal of mimicking a site's pre-settlement hydrology by using design techniques that infiltrate, filter, store, evaporate, and detain runoff close to its source. Because LID uses a variety of useful techniques for controlling runoff, the designs can really be customized according to local regulatory and resource protection requirements, as well as site constraints. So LID can be a feasible and prudent alternative in a lot of cases and incorporates a lot of green infrastructure techniques. And so you'll hear green infrastructure built into the conversations around low impact development. Green infrastructure are best management practices used to manage stormwater runoff and meet the goals of low impact development. Green infrastructure should be evaluated for placement around the site to maximize infiltration. But keep in mind that, yes, there can be challenges specifically surrounding clay soils, high groundwater tables, or contaminating groundwater or soils. But the next few slides, I'm going to touch on specific BMPs that may include some green infrastructure. The riparian buffers are a BMP that should be considered within your EGLE applications. It's non-structural, meaning there are no permanent structures that need to be built in order to achieve the specific BMP. It has great value and utility for virtually all types of development proposals and land uses, but it does probably work better on larger sites. This picture here shows how it can be divided into different zones that include various vegetation to enhance the quality of the body of water. So the first zone closest to the body of water is typically 25 feet wide with very restricted passive uses. The second zone is typically over 50 feet wide with less restrictions, but still more recreational uses. And the outer zone is typically 20 feet wide and allows for more activities, but still no actual development. So these are concepts that are taught frequently through things like the Natural Shoreline Partnership to individual homeowners, but they've not been historically proposed much on larger development sites. But this is something that EGLE will often bring up during pre-application meetings or before the design phase as a way to encourage applicants to provide green spaces, provide better stormwater infiltration, reduce threatened and endangered species impacts. Riparian buffers are a really, really good resource to have. So I highly encourage you to bring this up to your clients and implement these buffers in your design. Another great best management practice that we're often discussing with applicants is to minimize pavement widths and lengths for any or all impervious surfaces. There are a ton of ways to reduce pavement, and there are quite a few examples in the LID manual. But to improve stormwater management and also reduce the amount of impact to the resource, we often ask for alternative roadway layouts, restricting on-site parking or on-street parking, and minimizing cul-de-sac radii, which there are some good examples of that in this picture on the right, not only reducing the size of the impact, but also reducing the total amount of impervious pavement. The parking spaces can be smaller, they can be slanted, they can incorporate compact car areas, traffic lanes can be narrowed, overflow parking can be constructed of pervious paving materials, reducing front yard setbacks to allow for shorter driveways, and alternative materials for patios, sidewalks, driveways, like something like permeable pavers can help specifically with stormwater management. Bioretention, for example, rain gardens is an urban area favorite, and for a good reason. Bioretention in general are shallow surface depressions planted with native vegetation to capture and treat stormwater runoff from rooftops, streets, and parking lots. These areas have a ton of benefits, including volume control, groundwater recharge. They moderate peak rate control and increase filtration. They are versatile and can be placed pretty much anywhere. They enhance site aesthetics, improve habitat, air quality, climate benefits, just to name a few. These are a couple different examples of bioretention. The top is something typical of a small residential rain garden with well-drained soil and appropriate vegetation planted, well suited for the soil type. And it's also planted very strategically to allow for water fluctuations and help dissipate stormwater energy. And the bottom shows a more technically engineered bioretention area with certain aggregate materials placed, overflow drainage system, and an underdrain. Infiltration is also a great BMP, and there are many ways to achieve this. I've got a few up on the screen, but dry wells like seepage pits, French drains are subsurface storage facilities that temporarily store and infiltrate stormwater runoff, usually for smaller drainage areas. Infiltration basins are shallow surface impoundments that temporarily store and infiltrate runoff over a period of several days, typically for larger drainage areas. Infiltration berms create a barrier to flow, retaining flow for volume control and redirecting it. Infiltration trenches are more for conveyance, but allow for some infiltration in smaller drainage areas. Subsurface infiltration beds are basically rock storage beds below other surface areas. And then bioretention, again, can also include some infiltration or may be used in combination with some of these other BMPs. Couple examples of those. The top picture shows an infiltration berm, temporarily storing and redirecting water with some appropriate vegetation, again, planted in certain areas. And the bottom is a typical engineered infiltration basin schematic showing the inlet, the 2-year level, the 10-year level, and 100-year level with outlet structures, backup under drain pipe, emergency spillways. So these are items on this slide that should be included for EGLE JPA permit application processing, especially for those larger development projects. Providing this information upfront will likely avoid back and forth correction requests or additional questions with EGLE staff on stormwater concerns. So in addition to your site plan requirements and other JPA requirements, stormwater infrastructure should be clearly labeled on your site plans and cross sections that shows their relation to regulated features. So this means we'll also want to see the locations of any inlets or outlets and emergency spillways. Stormwater calculations should be included, and EGLE staff typically ask for this information. EGLE staff are going to want to know what the design storm event is for the stormwater infrastructure, pre and post development runoff rates to ensure that it's staying the same, and any calculations that may have been used to determine water quality, channel protection, or flood control volumes. And if you are including specific BMPs or LID design, it is very helpful to explain that in the JPA. There are a couple of sections in the narrative portion, specifically the alternatives analysis or the project compensation analysis. That allows you to explain best management practices utilized or ways you are proposing to improve the resource. Depending on the infrastructure or BMPs proposed, especially if you're not proposing any BMPs, then there may be some additional information needed to justify your alternatives analysis. So for example, if the applicant is stating that an infiltration BMP is not possible to avoid and minimize impacts, then documentation of the soil borings for that location should be provided. If there's contamination or sediment sampling that needs to occur because of sediment testing policy, then the results of those surveys would need to be provided. If part of the BMPs is to construct a wet detention basin with native wetland plants, then a planting plan with a list of species may also need to be included. So those are just some examples. But all of the BMPs we went through are in that LID manual by SEMCOG, but there are several other great resources for technical assistance on stormwater BMPs or even just general information on what you should include when you design these projects, especially for larger developments. So a good link to save is this NPS BMP manual, that's non-point source BMP manual. There's other design references and water quality program specific information for MS4 communities as well. These are all on our website. Applicants have a couple of options for EGLE assistance when it comes to planning a project, essentially for improving communication and coordination with each other, as well as smoothing the permit process and administrative completeness review. EGLE offers pre-application meetings, which are on-site meeting or in-office or virtual meeting with a small fee to discuss a project and determine if a permit will be needed. For when wetland boundaries need to be confirmed or delineated, EGLE offers the Wetland Identification Program. If you have a large, complicated project with difficult stormwater considerations, we would recommend the pre-application meeting. This is the best way to talk to the permit processor, establish expectations for the project, talk about how the application should be submitted and what sections should be completed. I do recommend submitting this as early as possible in the planning process prior to submitting the application, ideally when it's at a stage where there's good preliminary information and you can include as much as you can, but early enough so that if we're discussing modifications or action items, that those can be done with enough time to submit a permit application. The more information provided in a pre-app request, the better prepared EGLE staff can be, and then the more productive the meeting. So a few key items is to provide info on all the water resources potentially impacted by your proposed project, any preliminary plan design, stormwater designs, wetland delineation, and your project purpose. Again, our website has a lot of different help documents as it pertains to things like MyEnviro, the JPA, the permit categories. So please check out michigan.gov/joint permit, and you'll also find frequently asked questions, a flow chart showing the permit process, sample drawings, specific project assistance, and then links to other programs and helpful materials. Okay, so to summarize the big points we talked about this webinar, the stormwater is an impact to our water resources, and how much of an impact is going to be dependent on things like location, design standards, construction methods, and ensuring that within your project design are implementation of best management practices that address both water quantity and water quality. Avoidance and minimization of these impacts can be achieved in a ton of different ways, as we saw, both site-specific and design-specific, but please reach out to district staff if you have questions or if you need clarification on what requires a permit. So with that, that's all I got. Thank you, guys.
Okay. We have a few questions here. The first one, and I think it might be back on slide, I don't know, maybe 7. It's where you had the figure 1.2 over to the right of the I think it's the avoid and minimize text.
Okay, hold on.
Yep, okay. The question is, does figure 1.2 suggest that post-urbanization with proper stormwater management is more effective at flood peak attenuation than pre-urbanization conditions? And while you try to find the slide, Ann and I were teams chatting about it. I don't know, Ann, if you want to take the first stab at it while Kate looks for the slide. Yeah, that one.
Yeah, I was, we were just thinking that we would generally say yes, water budgets, when you're doing your planning, water budgets should include consideration of runoff conditions from the impervious surfaces of development that exists in the area. And incorporating these kind of low impact methods into development projects can help both reduce runoff and manage water quality in ways that protecting wetlands, in ways that will protect the wetlands and address the watershed issues. I think that's generally getting at the question. Kate, you can take it from there.
I missed the question while I was looking for the
Yep.
slide. So can you?
Okay, and you know, I don't know, Todd might have thoughts too. It says, does figure 1.2 suggest that post-urbanization with proper stormwater management is more effective at flood peak attenuation than pre-urbanization conditions? I don't know, Todd or Kate, do you have anything to
Well, yeah, I'm
add to
trying to
what
figure
Ann
out
said?
it does appear that way based on this graph. But what it also appears that there's more water running off. The area under the curve is larger for post development with stormwater management. And I think that it doesn't necessarily reduce the flood peak. The flood peak's still the same, and is actually extended out further. So I think that's really potentially regarded to maybe a change in infiltration by the impervious surface. We have more water running off, and therefore it extends longer. But it is. I'm not sure what this graphs. It does seem a little weird that it's significantly better, I guess.
Maybe if there's more discharge, like you
Right,
mentioned,
right. I
and
think that's
that
what it's
peak flow
showing.
is consistent, then the only variable to change is to um, make the discharge basically extend the time over which it occurs, right?
Instead of going up, it's going out. I think that is
Yeah,
right, Nicole.
slow it
Yep,
down.
Yeah,
yep.
I think this graph is really getting at like a lot of the stormwater management techniques are also designed to increase the amount of time of infiltration. So I think that's the major point of this is like that's not only does it address those peaks, but it does improve infiltration.
And yeah,
Okay,
slow runoff rates, I think
Mhm.
is what's going for. Yep.
all right, another question, and this, maybe we can all chime in here too. Is EGLE requiring more than silt fence for protecting inland lakes during build development? Silt fences do very little to protect erosion from entering lakes, particularly in steep slopes. So my answer to that is I've sat in on some of the EGLE soil erosion trainings in the last couple of years, and I think there is overall recognition that even though silt fence is helpful, it shouldn't be the only thing being used. So I think my feedback would be it should be part of a overall plan that includes other things. I don't know if anybody else, and Kate, Todd, Nicole, any thoughts?
No, I think that's right. I mean, I think whoever's designing the stormwater or sediment control plan should be considering slopes, and considering the receiving water bodies. So we've seen it where you've got multiple layers of silt fence. You've got additional things where if you are disturbing your slopes, you're stabilizing them with erosion blanket immediately. So I think there's things that can be done. Proper management and maintenance of those silt fence is one of the key to all those trainings, Amy, that I think you probably went to. They got to be inspected and they got to be maintained, and that's the biggest problem is failure more than ineffectiveness, I think.
Okay, if no one else has anything on that, this might end up being our last question. See if any more. Oh, maybe some more coming in. Can you please discuss tips, BMPs for soil decompaction?
That's a tough one. I think in general, I mean, this is kind of a non-answer, but trying to avoid compaction
Yeah.
first as much as possible is going to be the best management practice. But if it's already occurred, that can be tricky. We do some of those decompaction techniques that utilities use or other companies might use, especially for a larger area, can result in a lot of soil disturbance and be regulated. So I think there is some caution to be had about some of those techniques if it might disturb more than it is intended to help. But otherwise, I think a lot of depending on your area, like air spading is something that people will typically do for decompaction. I'm not sure if anybody has anything else to say to that, but I think
I don't
avoidance
either. It's a
first.
good, yeah, it's a good question. Once it's compacted, yeah, it's tough if you're going to drive heavy equipment over it for site grading. It's gonna take a lot of effort and a long time to decompact.
Yeah, it's a lot of planning ahead of time to ensure that equipment is where they need to be, right, in order to construct it, not going in areas that are not necessary for site development. So a lot of site prep ahead of time to ensure that the areas you don't want to compact stay that way.
All right, I think this is our last question. I'm reviewing site plans for stormwater items, and it's been brought to my attention that the current BMP manual is not up to date. Any planned revisions? And I can answer that one. So our non-point source program is updating the BMPs sort of on a rolling basis. So they have some updated ones, they're working on some more updates, and there's like a schedule to basically continue to update the manual. So I guess stay tuned. And if you have one that you think is problematic, you can reach out to Kate, and we can get in touch with our non-point source folks and ask them if they can move it up in the schedule.
Yeah, I think the preferred manual is probably the for sure the SEMCOG lid manual. It's by far more up to date than the DEQ manual. So appreciate you guys updating, Amy. Make it happen. But the lid manual is really good resource. And based on my experience, what EGLE requires for like first flush determinations or calculations is they're using the SEMCOG procedures. Perfect. So that's all the questions we have. I appreciate everybody's time. Kate, outstanding job as always. So thank you. And we will see you guys at the next one. Sign up for the conference. Remember that. Thank you all.
Thank you,
Thank you,
everyone.
guys.